Okay guys, so lesson 7.3 is addition and subtraction formulas. There are a lot of these formulas that you kind of need to be aware of. So I wrote them all out in one section here. So you may want to pause this and write all those down. And then also the cofunction formulas, which can come in handy as well. So all of these. So cofunctions, it'll come up later in the lesson, but let's start out with just this example one here. Oh, I said it comes up later. No, it doesn't. It comes up right here. First thing. All right, so it says express as a cofunction of a complementary angle. So first of all, if you think about what complementary means, it means 90, they add up to 90 degrees, right? So if you think about that in radian mode, that's pi over 2. So hopefully that should make some kind of sense with this right here, why this pi over 2 is happening. So I'm going to go by these. So when I'm talking about tangent right here of some value, my answer is going to end up being cotangent of some value, okay? So the first thing I have to do is come up with what is my pi over 2 minus this u value that they gave me here. So in this case, I wouldn't use pi over 2, I would use 90 degrees instead because it's in degrees. But if you do that and I have degrees and minutes, I have to go a little bit further here. So I'm going to take my 90 degrees, I'm just going to do this kind of off to the side. I need my 90 degrees minus my 37 degrees and 50 minutes. That's a degree symbol right there. Okay, so that means I need to change this into degrees and minutes. I would just change it to 89 degrees and 60 minutes because there's 60 minutes is a degree, so then I could just rewrite it like that. So 90 degrees is the same thing as 89 degrees and 60 minutes. And now I'm going to minus that 37 degrees and 50 minutes from that. I don't know why I put a 5 there. 37. Okay, so that means I'm just going to take 89 minus 37. 89 minus 37 is 52. So it's 52 degrees. And then 60 minus 50 is 10 minutes. So that means my answer then for this one would be cotangent of 52 degrees, 10 minutes. Okay, so then part B, now we're in radian mode, so now I have to think about pi over 2. So I need to take my pi over 2 minus my pi over 3. And you could think of this as just fractions, 1/2 minus 1/3, right? So you can use a calculator for that, or you could get a common denominator. So I would say that this is the same thing as 3 pi over 6. This right here is the same thing as 2 pi over 6. So 3 minus 2 would give me 1 pi, or just pi over 6. So again, cosine, when I look back up here, my cosine for my cofunction formulas is sine. So my answer for this one would be sine of pi over 6. Okay, and then this one, cotangent. So if I look up here, cotangent takes me back to tangent. Again, I've got a degree, so I'm going to think about 90 degrees instead of my pi over 2 idea. So 90 degrees minus my 61.87 degrees. The good thing about this one is this is not in degrees and minutes, it's just in a decimal form. So I can literally just take 90 minus 61.87. So if I do that, I get 28.13. So that means my answer then is tangent of 28.13 degrees. Okay, last one. So this one I think a lot of people get confused by because it's a number without pi attached to it, but it's not a degree. So there's no degree symbol. So it gets kind of messy, basically, is what's going to happen. So it's in radian mode because there's no degree. So it's pi over 2 minus that value right there, which in this case is 1/5. So in order to subtract those, again, I just get a common denominator, just like I did up here. It doesn't matter if it has pi or not. So I'm going to make my common denominator 10. So 5 pi over 10 minus 2/10, which means I end up with this weird 5 pi minus 2 all over 10, like that. It's okay to leave it like that. So I'm going to write this. Remember, it's cosine, so that means it ends up sine of 5 pi minus 2 all over 10. That is your answer. If you feel better about it, if you have parentheses around it, that's fine also. Okay, so that's not too bad. That's where those co-function formulas come in handy. It's not a huge deal. Just remember it's either pi over 2 or 90 degrees that you're taking it away from, and then that's how you write your final answer. Okay, so I'm going to keep this page nearby though, because I'm going to need these a lot in these next couple of examples. So in example 2, they want me to find the exact values. Well, the first one is super simple because it's just sine of this plus sine of this. That means I just need to go figure out what the sine of those values are. Now, if you remember your unit circle, that is amazing. That's awesome. If you don't remember it, remember you have that reference sheet, or you can use it out of your book. So this right here is my unit circle. I was looking at sine of 2 pi over 3. So if I go to 2 pi over 3 right here, my sine value is the square root of 3 over 2. So this is the square root of 3 over 2 plus the sine of pi over 4. Sine of pi over 4 is the square root of 2 over 2. So if I add those together, they have common denominators. I could just write it as the square root of 3 plus the square root of 2 all over 2 in one fraction. That's how you will see the answers written in the back of the book if you look back there. So that one wasn't too bad. It's pretty easy. The next one, they said, I want to know what the sine of 11 pi over 12 is. And if you look at the unit circle, 11 pi over 12 is not on there. So you'd have to then like figure out, oh, where does that end up? I got to find that little bitty spot. So instead, they tell me in this problem to use the fact that 11 pi over 12 is the same thing as 2 pi over 3 plus pi over 4. So they want me to like break this up. So instead of writing it like this, they want me to say this is really the sine of 2 pi over 3 plus pi over 4 instead of 11 pi over 12. Okay, so if I do that, then all of a sudden I have one of those rules from over here, one of my addition or subtraction formulas. So in this case, I was talking about sine, and it was addition. So when I look at these rules down here, I'm looking for the sine with addition. So that means this translates to being, how can I leave this over here next to it here? Okay, so now I've got this formula right here. So this is the same thing as sine of that first one, 2 pi over 3, times cosine of the second one, pi over 4. There we go. I was kind of blurry there. Okay, and then plus, so right here, plus, now I do cosine, sine. So plus cosine of the first one, 2 pi over 3, sine of the second one, pi over 4. Okay, so that formula right there came from this line right here. Then I can go in and find each of those pieces because those are on my unit circle. So now let's go back to the unit circle. I keep kind of going back and forth between these two resources. So the first one is 2 pi over 3. I already found that one up here. It was the sine of 2 pi over 3 is square root of 3 over 2. And I'm going to multiply that times the cosine of pi over 4. So go to pi over 4 cosine, square root of 2 over 2. Plus the cosine of 2 pi over 3. So right here, cosine would be negative 1/2. Times the sine of pi over 4, which is the square root of 2 over 2. Okay, so now I need to simplify this. So multiply straight across on these. So the square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4. And then instead of putting a plus right here, I'm going to put minus because of this negative right here. And then that would be the square root of 2 over 4 on the bottom. So again, just like I did up here, I could go ahead and combine those and write it as one big fraction. So the square root of 6 minus the square root of 2 all over 4. And I would stop there. Okay. Example 3, they want me to express a trig function as one of one angle. They want me to express this as a trig function of one angle, not separate things. So they basically just want me to use those rules again. So let's go back over here. In this one, I see a sine, a cosine, a plus, and then a cosine sine. That seems very similar to what we were just doing, right? So a sine, cosine, plus cosine sine. So that's this one. So that translates to just being the sine of the u plus v. So the first angle plus the second angle. So in this case, that becomes sine of 57 degrees plus 4 degrees, which is really just the sine of 61 degrees, because 57 plus 4 is 61. Okay, this one right here, something weird that happens sometimes, if they put a negative in here, I would pull that out front. You got to get that out of there. So when I say that, I guess sometimes you wouldn't, right? Because if it was cosine of -2 right here, that's the same thing as just cosine of 2. So you have to go back to those negative rules. In this case, though, if it's sine, that is the same thing, so let me write it down here, as negative sine of 5. The cosine of 2 can stay the same. And then the same thing with this one right here. I'm going to pull that negative up front, so I'm going to call that minus. The cosine of 5 is going to stay the same, and now this is sine of positive 2. So I just pulled the negatives out. Then I'm going to factor that out because there's none of these rules over here. None of these have a negative up front. They do have negatives in here or minuses, but they don't have any up front. So I'm going to try to factor this out. So that means I have sine of 5 cosine of 2 plus cosine of 5 sine of 2, like that. Now it looks better. It looks kind of like the same idea we had up here. So that means I end up with, I've got a negative up front, and then I've got my sine. That's what this rule was, remember, it was sine. So look back at your rules. And then the first one, which was 5, plus the second one, which was 2. So that's what I've got right now, but that is the same thing as saying I've got negative sine of 7, like that. But really, that is the same thing as saying sine of -7. So they want you to go ahead and pull it all the way back in, just like they did here. Like if they list them like this to begin with, that's how they want their final answer to look. So that's sine of -7. Okay, the next one, example 4, they want me to use given conditions to find the exact value of the expression. So these may take a minute. I may break off after A and put B in the second video. So let's start out with this one. They're telling me that my cosine is 24 over 25 and that the sine of alpha is less than 0, which tells me it's negative. Sine is negative. And then they give me this. So these are my conditions, and then this is what they want me to find the exact value of. Okay, so I'm going to have to think about this in a few ways. First, I'm going to think about this cosine. What are they telling me there? So I always make just a coordinate plane on my two conditions and say, what does that mean? Where does it end up on this coordinate plane? So in this one, it's telling me that the cosine is some positive value, right? So if you look back at your unit circle, where was cosine positive? Cosine, remember, is your x value. So cosine is positive here and here. All of those, so in quadrant 1 and quadrant 4. So right here and right here, it's positive. There we go. Okay, this one is telling me that my sine of alpha is negative. It is less than 0. So where is sine negative? So let's look at this. Sine is your y values, right? Where is your where are your y values negative? Down here and down here. So quadrants 3 and 4. So that means right here and right here. So I want to know, where do these match up, because that's what I'm talking about. So this one was in quadrant 1. Quadrant 1 is not represented there. This is in quadrant 3. Quadrant 3 is not represented here, but quadrant 4 in both of them is represented. So that tells me I'm talking about quadrant 4. Okay, using that information, then I'm going to go ahead and draw out what they've given me. So I'm just going to do it over here off to the side. So I know I have some value down here in quadrant 4. I'm just going to put it right there, and I'm going to draw myself my right triangle given that. So I've got this angle right here is that alpha that they're talking about. So what they told me was my cosine was 24 over 25. So if I look at this value right here, cosine is, if you remember SOHCAHTOA, that'd be adjacent over hypotenuse. So my triangle's kind of upside down here, but that would be this side over this side. That's my 24 and my 25. So 24 over 25 is adjacent over hypotenuse. Okay, then what I could do is use Pythagorean theorem to find this piece right here. So if I did 24 squared plus I don't know squared equals 25 squared, and I solve, I end up with 7. Now, one thing that you got to be careful about is this point is down here, right? So I know that my x value is 24. My y value, though, went down. So I know that it's 7, but in this case, it would be -7 because I went down to get to that point. So that's a -7. Okay, so then I need to figure out what the value of my alpha plus pi over 6. So cosine, I'm just going to rewrite it here, alpha plus pi over 6. Well, let's use my rules here. I don't know why this keeps going blurry, sorry. Okay, so this, go back to my rules over here, cosine, and I'm doing addition right here. So cosine with addition tells me I've got cosine, cosine minus sine, sine. So I'm going to do cosine of alpha times the cosine of pi over 6 minus sine of alpha sine of pi over 6. So that's just that rule again. I'm not coming up with that on my own. I'm getting that from those formula rules, those addition and subtraction formulas. Okay, so now I need to go in here and see what do I know, what do I not know. Cosine of alpha, I don't know that just right off the top of my head, but I can find it by looking at what I did over here. So actually I do know it right off the top of my head. They gave it to me right there. So if I look back at this triangle though, it's adjacent over hypotenuse, which is 24 over 25, or just look at what they gave you to begin with. So 24 over 25 is that piece. If you don't have it given to you right here, so maybe they asked me for sine of alpha, which they do right here. They didn't give me that, but I can find it by looking over here. All right, then cosine of pi over 6, I can find that by looking at the unit circle. So over here, pi over 6, cosine is the square root of 3 over 2. So this is the square root of 3 over 2. Minus my sine of alpha, that's what I was talking about over here. So here's my angle, that's my reference angle. Sine is opposite over hypotenuse, so that's -7 over 25. So be careful with your signs. If I forgot that that was negative, I would come up with the wrong sign right here. So just watch that. And then sine of pi over 6, remember I'm going to go back to my unit circle again. Pi over 6, sine would be 1/2. Okay, then I'm just going to simplify this. So let's go ahead and multiply those through. 24 times the square root of 3 is 24 square root of 3. Not much I can do about that. Over 25 times 2 is 50. And then this would become a plus. 7 times 1 is 7. 25 times 2 is 50. So again, I have a common denominator. Let's just go ahead and put them together. So 24 square root of 3 plus 7 all over 50. So these get kind of messy. You really have to pay attention to what's happening in each of the given conditions. Where does that put you on your coordinate plane? Then draw out that triangle that was given to you based on this information they gave you right here. You can fill that in and then fill in any missing pieces with the Pythagorean theorem and then use your formulas to move forward from there. So it's a lot of work. All right, so I'll stop right there. I'll do the second one of these and a couple more examples in the next video.